Hi folks, Chris McClure here. We are now going to talk about relationship between two variables, typically between y and x, but it could be between any other two variables. And this relationship is called variation. There are going to be a handful of different types of variation that we'll discuss. The first one is going to be the direct variation, in which we could write one variable as a multiple of some other variable. So if you increase one variable, that leads to an increase or decrease in a linear fashion for the other variable. It's going to be in this form right here, where you have y is equal to kx, where k is some constant. Could be 2, could be -3, whatever. And like I said, that could be that slope k, that constant of proportionality, is going to be the slope of the line. Again, it could be positive, could be negative. Now, for the purpose of our discussion, let's just assume that k is positive. But whenever you could write y as a constant multiple of x, then we say that y varies directly with x, or that y is directly proportional to x. Okay, and k is called the constant of proportionality. Again, we're assuming that k is positive and also that x is going to be non-negative, at least for the purposes of this discussion. More generally speaking, we could allow k to be negative and x to be also negative, but for the purposes of this class, so let's just assume that k is positive and x is non-negative. Let's see an example of direct variation here. For this example, we have monthly payment of $P on a mortgage, and that monthly payment varies directly with the amount borrowed B. So that means that P could be written as a constant multiple of B. That's really what that means. If the monthly payment on a 30-year mortgage is $5.95 for every $1,000 borrowed, find a formula that relates the monthly payment P to the amount borrowed for B for a mortgage with these terms. Then find the monthly payment P when the amount borrowed is $125,000. So that's an example of how these problems go. They'll typically give you just enough information so you could solve for your constant of variation, or constant of proportionality k. And here the clue right here says that the monthly payment on a 30-year mortgage is $5.95 for every 1,000 borrowed. So we could, write 5.95 here is equal to k times 1,000. And then you could solve for k. Now I've got some written text here, so I'm going to erase this ink here. And let's go ahead and go forward here. So we'll go ahead and write P is equal to k times B and solve for k like I wrote earlier. So that means that k is equal to 5.95 divided by 1,000, which means k is equal to 0.00595. So going back to the equation, P is equal to KB, replacing k by 0.00595. And then we could answer the final statement in the form of a question. Find the monthly payment P when the amount borrowed is $125,000. So we will replace B by 125,000 and take 0.0059 times 125,000, and you'll get P is equal to $743.75. Okay, so there's an example of a direct variation type of problem. First thing that you want to write when you see in the statement of the problem is that there are direct variation or varies directly, you want to write this sort of equation right here, where you have this first variable, p in this case, is a constant multiple of the second variable. And then you solve for that constant by looking at the clue that they give you in the statement of the problem. And then finally, once you have solved for k, then you can go ahead and answer the final question. All right, now let's talk about inverse variation. Inverse variation means that your one variable y could be written as some constant k over x. So that means that if you increase x, that results in a corresponding decrease in y. As you could see for this example, this graph right here. This could be the graph of y equals 1 over x, or 2 over x, or some other number over x. Of course, we cannot let x ever be equal to 0. We're assuming that k is positive. Here's an example where we are going to solve an inverse variation problem. We're going to solve this problem involving maximum weight that can be supported by a piece of pine wood. So let's take a look at this picture right here, this piece of pine board that spans this chasm here. Maximum weight W that can be safely supported by a 2-inch by 4-inch piece of pine varies inversely with its length L. So W varies inversely with L. Just translated that from English into mathese by writing this equation right here. And then we could take a look at this next statement that says experiments indicate that the maximum weight of this piece of wood can support is 500 pounds. So W is going to be 500 over K, and the length is 10. So that means that K is equal to 5,000. So we can go back to the original equation, substitute 5,000 for K, and then looking at this last statement, write a general formula relating the maximum weight to length L in feet. So there it is, except I need to fix this. Excuse me. There, this needs to be L there. There we go. That says the weight varies inversely with L by this relationship here, this formula. Find the maximum weight that can be safely supported by a length of 25 feet. So 25 feet, that's going to be L now. So if a board is 25 feet, replace L by 25, and you're going to end up with 200. So that means that if you have a board that's 25 feet going across the chasm, only supported by the ends, that the maximum weight will be 200 pounds. Okay? I'm going to erase all the ink. And then I've got the written annotations there. Okay, 200 pounds. Here's a graph of this function, right? Well, this function when W is 5,000 over L. So, and this shows that when the length is 10 feet, the maximum weight is 500. But when the length is 25 feet, the maximum weight is 200. Now we're going to talk about joint variation or combined variation. Through examples here. The loss of heat through a wall varies jointly with the area of the wall and the difference between the inside and outside temperatures, and varies inversely with the thickness of the wall. So let's go ahead and write an equation that shows this relationship. We're going to let L represent heat loss, let T represent temperature difference, A is the area of the wall, D is the thickness of the wall, and then here is that relationship here. Remember, when we said that the loss, L, varies jointly with the area of the wall, that's A right there, and the temperature difference, T. So when you see joint variation, that means that you're actually multiplying those two variables together. And then, of course, varying inversely with the thickness of the wall, which is D. And that goes in the denominator. And of course, you have a constant out front here. And you would normally in the problem be given enough information that says that the loss is equal to so much when the area is a certain amount and the T is a certain amount and the D is a certain amount. Enough information for you to solve for K, and then you could solve some problem. Now let's do another example here. Force of the wind on the window. The force capital F of wind on a flat surface positioned at a right angle to the direction of wind varies jointly with the area of the surface and the square of the speed V of the wind. So we've got area A of the surface of the window and the area V, the square of the speed V of the wind. Okay, so what is going to be our equation? There's our equation that says that force varies jointly with area and the square of the speed. Now we need to solve for K. A speed of 30 miles per hour, that's V, so we're going to have 30 squared there. Blowing on the window, measuring 4 feet by 5 feet, so that's an area of 20 square feet, so you're going to have 20 times 30 squared, and has a force of 150 pounds. So we got F is equal to 150. So we have enough information to solve for K by plugging in those numbers. So if you had to take 20 times 30 squared, well, 30 squared is 900, times 20 is 18,000. 150 divided by 18,000 is 1 over 120. So that's what K is. So you can go ahead and write your equation for force, and then what is the force on a window measuring 2 feet by 3 feet? Well, that means area 6 square feet, and 70 miles per hour is the speed, so you have 70 squared. So you got a 1 over 120 times 6 times 70 squared. That works out to be 245 pounds. So now you saw some examples of joint variation, direct variation, inverse variation. Okay, so that's it for today, folks. That marks the end of Chapter 2. Next time we will begin in Chapter 3. Look on my math lab for your end of chapter quiz. Okay, and we need to start talking about your midterm exam, testing you on the material through Chapter 4. Okay, talk with you later.